Hopefully you understood a little bit yesterday about completing the square. Let's just quickly go over your homework. Let me turn off my phone. The first part, of course, you had to go through and just figure out which number to complete the square. I'll just pick a couple of these that look like they might be a little more challenging to go over. How about number 6? So in number 6, we're taking remember the key is b divided by 2 squared. So in this case it would be negative 38 divided by 2 squared, which would give me my negative 19 squared. And of course we know that any negative number squared is going to be a positive number, and that's where we end up with our 361 that would be needed to complete that square. So if you have any questions at this time, Ms. Hotzelt's with you today as well, and if she needed to, she could stop the video at this point if she needed to and do any further explanation that she needs to for any of you that were lost yesterday. Alright, then if we continue on down, I ask you not only to complete the square, but to then go and rewrite it as a perfect square. And so let's just pick a couple of these, or how about number 16? So if I pick number 16, again, I'm doing b divided by 2 squared. So in this case, b is 18. So we end up with 9 squared, which is 81. And that's what we need to complete the square. So then we have r squared, and you're welcome to use x if you'd like. And we know when we rewrite that as a perfect square, we'll end up with r plus 9, because we always use whatever we get when we do b divided by 2 in our perfect square that we end up using. And again, at this point, if you feel there are any you need further questions with, you can pause the video and Ms. Hotzelt will help you with that as well. Okay, so today we're going to take this a step farther. This is straight from your book, of course. I always like to put that in there. I'm not really going to say much about it because you can refer back to it. I think we're better off just to go through the examples and then you can refer back to what it's saying and maybe understand what it's saying. So if I wanted to solve this equation by completing the square, basically what I want to do is I want to get my variables on one side and my numbers on the other. So in that case, I'm going to have x squared, and I'm going to add 6x to this side, because I want to make this number right here, of course, I want to make it complete the square. So I go through and say, all right, let's use our little process that we know. 6 divided by 2 squared, 3 squared equals 9. So that means I need 9 to complete the square. But we know we can't just go around adding 9 to one side without adding it to the other. So I'm going to add it to the other side. And when I do, again, I'm going to use that 3 that I got when I do b divided by 2 in my perfect square. And then I have my 27 plus 9, which is going to give me 36. Now, it's always great when we have a perfect square. And in this case, we do. So what I have, and what this is avoiding, is us having to use something we're going to use next week called the quadratic formula. It's also helping to direct us what we're going to get to in the end of today's lesson with vertex form, which we are already fairly familiar with. But I'm going to take the square root of both sides. And we know the square root of a square, of course, is itself, so we have x plus 3. And the square root of 36 is going to be 6, but we know that we do plus or minus 6. So I'm going to end up with two problems. X plus 3 equals positive 6, or x plus 3 equals negative 6. And just like we were doing simply earlier when we factored, we are going to possibly, in this case, get two different zeros. So my two possible answers are x equals 3 and x equals negative 9. Now let's just check that on our calculator and see if it agrees. We like to visually check when we can. Alright, so I'm going to put the original function in. And basically I'm going to move everything over so that I can check it. So I have x squared plus 6x minus 27. I'm just moving everything over to the same side. And I'm looking for my answers to be -9 and +3. And by my picture, that looks correct. So I'm going to go to my table. +3, see the 0 there? Let's go to -9. See the 0 there? So yes, I did this one correctly. Now, again, at this point, if you needed to pause the video and kind of comprehend what we just went through, work through it yourself again, get Ms. Hotzelt to help you, you can do that at this point. But I'm going to move on to example 9. All right, so let's look at example 9. And we're going to go through the same process. Okay, so I have 2x squared plus 8x equals 12. And if we're going to complete the square, we want our variables on one side and we want our numbers on the other. Now, if you notice in this particular case, I do have a common factor. So I'm going to pull out that common factor. All right, so before I go ahead and complete the square on this one, the first thing I need to do is simplify it because we don't want to deal with the 2 outside of the x squared. So I'm just going to divide this entire function by 2 and rewrite it. Now let's just forget that 2 was ever there, and we're going to go through and complete the square. So I'm going to do 4 divided by 2, which is my b divided by 2, which is 2 squared, which is 4. Add 4 to both sides. And of course I end up with my x plus 2 as my perfect square equals 10. Now this one's not going to turn out and be quite as pretty. We still are taking the square root of both sides. But you're going to find that this is a very useful method, especially when you have answers that don't turn out quite as nice and pretty. So I'm going to get plus or minus the square root of 10. Now the square root of 10, if I tried to do my upside down division like we talked about yesterday, it's not going to do anything. So there's no need to mess with it. I'm just going to leave it as the square root of 10. But I do need to subtract 2 from both sides. And we're going to leave it in this form, -2 plus or minus the square root of 10. So basically I've got 2 answers here, and it's okay to leave it like that. Or if you needed to, you could write it like this. Either way, you have 2 answers. Now, I believe I've already got this one for time's sake in my calculator. And again, I left it in its original format because, you know, we like to always check things with our original format in case we made a mistake along the way. So I just moved the 12 over and I graph it. And since this one is not going to show up in my table, I'm going to use that value function that I have. And let's type in the -2 minus square root of 10 first. And you can see your y equals 0. And then your -2 plus the square root of 10. And you got your 0 as well. Okay, so I have completed the square, and again, I've got some irrational answers, but that's perfectly fine, and I'm going to leave them in this form. All right. Another thing we can do, and you're going to practice some of those in your homework, and again with a video you can feel free to pause it and practice at any time, is one purpose, and I know Christian in my second block had asked about this, I think it was Christian, about getting functions into vertex form. How do we do that? Well, here's how we do that. We use it by completing the square. The problem is we're not working on both sides, we're only working on one side, so we have one little modification to make. But the first thing I do is I still go ahead and separate it like we've been separating it into my variables and into my constants. And I'm going to still go through and do the b divided by 2 squared. So that's going to be 10 divided by 2, which is 25. But here's the problem. I'm staying on one side of my function. So what I want to do is I want to add the 25 on this side because ultimately to get vertex form, I'm going to want this right here. But because I added 25 here, to balance it since it's on the same side of the equation, I need to subtract 25 here. So it's like I added 25 pounds and subtracted 25 pounds to make it stay the same value. And that's going to end up being x plus 5 squared minus 38. And now I have it in vertex form. All right, so let's just check this and see if it's right. Okay, so the way you could do that is you could take your calculator, and I know you're probably going to want to pause this one and go back and just do it again. And we will be working on this more next week as well. So I'm going to put my original function in there. So I have x squared plus 10x minus 13. And let's put what we think is vertex form. And you could use the ball and chain here. I'm using my good calculator because I'm on my tablet. And I've got it downloaded here, so it's going to be in color. So it'll make it a little easier to see. My graph's not going to be real in the screen, but I can fix that if I need to. All right, so let me do zoom 0 just so we can see it better. Not a very good picture, but you'll get the idea. Okay, so there's the first one. And see, it is the right function because it's completely going across it. And now I can identify my vertex. We know we have the x minus h plus k, and our vertex is the hk. So if you want to put this in the form like we talked about before, you can see that your vertex is going to be the point -5, -38. And we could check that on our calculator and just see. Put in my -5, and it does give me a -38. I'll make my window go down on the Y just a little bit more. See, it's going right down on that. I'm going to put it on -50 so we can see it a little better. And there we have it. You can see your vertex, so we did this correctly. All right, so let's keep moving. You can always go back and redo this and watch it again. It will be on YouTube, especially if you have access at home. All right, so again, we're going to do this one the same way. We're going to write it in vertex form, and then we're going to identify its vertex. Now, this one is not going to be quite as pretty. All right, so this one is not going to be quite as nice, but we're going to go ahead and divide the entire thing by 2 first. Of course, that'll be 3/2. All right, we can still complete the square, though. Fractions don't scare us, right? So we get -4 divided by 2 squared, which will be -2 squared. So I'm going to add 4 to both sides. Actually, I'm not going to add 4 to both sides. I'm going to add 4 to this side. I'm going to subtract 4 from this side because remember, we're all on the same side. So that gives me x minus 2 squared. And then I have 3/2 minus 8/2 if you wanted to do this in your head. Feel free to do it on your calculator. 8 divided by 2 is 4 if you wanted to do that. And you end up with -5/2 over here. And so I end up in vertex form. Now, because I'm doing vertex form, I've got to go back and remember that I did divide by 2. So what I'm going to do is I'm going to multiply both parts of this function by 2 to get my true vertex form. And then -5/2 times 2 would be -5. All right, now let's just check that out and see if it matches. All right, so I go into my calculator and I have 2x squared minus 8x plus 3. And I put in 2 times x minus 2 squared minus 5. And we graph it. And I have already graphed it, so you can't really see it as well. And it is on top. So when you do vertex form and you do have to divide, now back in this one, see, I didn't have to do that. But because A was not 1 there, I kind of take it out, get my form, and then put it back in. And I have my true vertex form. So my vertex here is going to be, because we're looking at, again, the form A and x minus h plus k. So that would be 2, and of course that's plus negative 5. So the vertex should be 2, negative 5. Let's just check it and see. It appears that that's true. You can look at your table and go to 2, negative 5 and see if it does what it's supposed to. It's going the wrong way. Alright, so if you remember how it's supposed to go on the y's in the same direction, see how it's doing negative 5, negative 3, 3, negative 5, negative 3, 3. So I have indeed found the correct vertex. Alright, one more of these, and then I'm going to let you start on your homework, and I'm sure you're going to need to do lots of practice with this. That's why I didn't give you many today. That and the fact that we do have a shortened class. Alright, first thing I'm going to do is rewrite this guy, because I just don't like the form he's written in at all. And then if you notice, I need to get a to be 1 in order to do this process. So I'm going to divide everything by 3. And I'm going to go ahead and move the 45 divided by 3 over. Okay, so now let's go through our process. B divided by 2. And this just takes lots of practice. So 6 divided by 2 squared. So I'm going to add 9. But because we're on the same side, remember we subtract 9. And that's going to give me x plus 3 squared. And then negative 15 minus 9 is minus 24. I'm doing that right in my head. Okay, now because I divided by that 3, I'm going to go back and put the 3 in, which means I'm going to multiply that 24 times 3. So I'm going to end up with 3 times x plus 3 squared minus 72. Now let's just do a little checking on our calculator and see if this is right. Alright, so in blue I'm going to put the original function. I'm just going to write it as it is on my paper so I don't make a mistake in my transferring. And then I'm going to put what I think it is in vertex form. And again, the ball and chain works really well here with your calculators. I'm going to go ahead and do zoom 0 because I know it's going to do weird stuff because that window is going to be really big. Okay, so there's my blue. And there's my red, and they look perfect. Another thing you can do, I didn't mention in any of the others, is you can look at the table and you can see that your y's match, and that should happen. If it doesn't, then you've done it wrong. Alright, so looking at my vertex form, okay, and we know if we rewrote that in vertex form, that would be negative 3 following the minus sign, and that would be plus negative 72, so that would be negative 3, negative 72 as my vertex. So let's see if that's correct. If we look at negative 3 and negative 72, and if you look on both sides of it, if you look at the table, you can see how it is indeed going in both directions. You can also check your value there. And yes, you can see that it is the correct vertex. Now, I know I've gone through this rather quickly. It is YouTube based. I know your tablets don't have access to YouTube, but you probably have computers at home that do, or your phones do. So you can go back and watch it on your own. Here are some problems I want you to practice. I want you to work on these the rest of the time. I do want these done Monday. So you can spend whatever time you have left working on these. Basically, in 2 and 4, you're solving the equation, and I want you to use the method that we used in class that we just learned. Use the methods we have used today. So like in 4, you'll complete the square. Alright, and then in 6, it simply tells you what to do there. 8 through 10, you're going to, again, use the methods we used in class today. to solve these. And then in 14 through 18, you're going to write them in vertex form and identify the vertex. That's the last few examples that we did. And then finally, 20, you're going to use the method we used in class today. So it's not that many problems. I do expect these to be done Monday. I don't see any reason why I shouldn't be here Monday. We'll take it one day at a time, but I will be checking for these on Monday. So use the rest of your class time now to practice. Go back and redo this if you need to rewind the video, or use Ms. Hotzelt there to help you as well. Have a good day and enjoy the pep rally.